20-1s, welcome to a new chapter. Moving on to rational expressions and equations. Well, what are they? Well, what they are is a whole bunch of big stuff with numbers and variables in fraction forms. Because a rational is basically anything that can be a fraction. So we are going to work with rational expressions. And because the word expression gets in, it's a fraction that has a numerator and a denominator that are polynomials. So now we are going to work with fractions that not only have numbers and variables, but they have polynomials in them. And it's something that looks like this. There's a rational expression with multiplication and division in it. What this unit is all about, it's fraction work. And we are going to, with fractions, add, subtract, multiply, and divide. With fractions. But the fractions have polynomials for numerators and denominators. So we have fraction work with polynomial work. But what you have to realize is when we talk polynomials, not only are we talking combining terms and things, we're also talking factoring. So we are looking at a unit where you have to work with fraction processes for all calculations, and you have to work with polynomials, including factoring. So these questions have a ton of information going on. Last unit, the radicals unit, was similar. Lots of little things to think about. This unit, lots of little things to think about. First thing we're going to do, this first lesson's really quite short, but understanding with radicals. If we just think back to radicals for a second, what was important about the radicals when we had expressions? Well, remember, a radical has to be 0 or positive. So we had to identify restrictions, what x could or couldn't be, so that we had something that worked. Well, it's really no different with rationals. We now have a fraction or multiple fractions, depending upon what's going on, but a fraction doesn't always necessarily exist. When doesn't a fraction exist? Well, a fraction doesn't exist if the denominator is 0. We can essentially have anything in the numerator, but if I have a denominator of 0, it just doesn't happen. So that's what we're going to talk about in this really short lesson. We're going to talk about NPVs, non-permissible values. These are values for our variables that make the expression undefined. And undefined means not exist. So when will a fraction not exist? When we have a denominator of 0. Numerator can be anything, but a denominator of 0 just creates something that's undefined. And we always have to consider our NPVs in this unit because of that. So we're looking at page 2. That's kind of what I've been talking about, but we're going to look at how to calculate NPVs. So what we understand for this first example is we can't have a value of 0 down here. We have 4 times s times r squared. We can't have this equal to 0. Well, this is about as easy as it gets. What value for s or r? Because we always have to determine NPVs for all variables. If we have multiple variables, we have to do NPVs for each. So in this case, s can't be what? Well, what would s be to create a value of 0? Well, if s was 0, we would have 4 times 0 times r squared. Anytime I multiply by a 0, I get 0. So in this case, s cannot equal 0. And it's the same thing for the r. 4 times s times, if r was 0, well, 0 squared is 0 times s is 0, and 0 times 4 is 0. So if r was 0, it creates a value of 0. So we can't have s or r equal to 0. Those would be the NPVs. The non-permissible values, r would be 0 and s would be 0 because they can't be 0. Now it gets a little confusing. An NPV, r equals 0, s equals 0, which is saying that s can't be 0, r can't be 0. I honestly don't care which way you see it. Different resources actually sort of show it either way. We're saying s can't be 0, so that means s equal to 0 is the NPV. We're saying r can't be 0, so the NPV is when r equals 0. It will create a denominator of 0, which just isn't allowed. So if we take another example on that page, we have 3x over x bracket 2x minus 3. So again, if I have this denominator equal to 0, that's a bad thing. Well, I have x times 2x minus 3. What would create a value of 0? Well, if I just started, x is equal to 0. Because what I have here are two factors. We have an x times a 2x minus 3. So if I had x equal to 0, I would have 0 times whatever this value is. And 0 times anything is 0. So we know that x cannot equal 0. But that's not it in this case. Because the other situation here is if this second factor, which isn't just a variable, but it's actually an expression. If that expression equaled 0, we would have x times 0, which would give us a 0, and that's just not allowed. So what here would create 0? Well, if 2x minus 3 equaled 0, we solve for x, add 3, divide by 2, and x equals 3 halves. If x equals 3 halves, it equals 0, and that's a bad thing. So x can't equal 3 halves either. The NPVs for this situation are if x equals 0 and 3 halves. Those are the NPVs. Those are the things that aren't allowed because they would create that denominator of 0. We don't want denominators of 0. It's just not allowed. Another one on that page? Give it a try. Well, again, we have a factor times a factor. We don't want this whole thing to equal 0. It would equal 0 if that or that equaled 0. If that factor was 0, 0 times this is 0. If this factor were 0, x plus 2 times 0 would be 0. So what would make a value of 0 here? X plus 2 equals 0. It occurs when x equals negative 2. So we know that x can't equal negative 2. But the same is true for this second factor of x minus 3. What would make x minus 3 equal to 0? Well, solve for x. If x equaled 3, 3 minus 3 would be 0, and something times 0 gives us 0. So x can't equal 3 either. So because x can't be a negative 2 or a 3, the NPVs for this situation are x equal to negative 2 and 3. Those are the non-permissible values. We can't work with that expression if x is negative 2 or 3. So hopefully you start to get the idea. But now we get 2p minus 1 over p squared minus p minus 12, this example. Well, now it's not as easy to identify our NPVs, unless what? Well, this whole unit, because we're dealing with polynomials, we always, you'll see, start a question by factoring the numerator and denominator polynomials. But really for us right now, because we're worried about NPVs, it's only the denominator. But I want to start by factoring the denominator. P squared minus p minus 12. We did a great big review, and there's a video for it on factoring last unit. If you don't know factoring, don't think you're finished with it because the radicals is done, because the quad equations was done. This rational expressions unit is factoring like crazy. Simple trinomial, what multiplies to negative 12 but adds to negative 1? Well, that would be a combination of negative 4 and 3. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So we have p minus 4 and p plus 3. That's another way to write that denominator. And what's nice about the factored form, well, now we can get our NPVs. Our NPVs will occur if p minus 4 equals 0 or if p equaled 4. Our other possible situation is if p plus 3 equals 0. We don't want that factor to equal 0. Minus 3, p equals negative 3. We can't have p equal to 4 or negative 3 because those give us 0. So our NPVs are when p is equal to 4 or negative 3. Any other value of p we can work with, but p equal to those two things isn't acceptable. Give this one a try, see what you come up with, and then we'll talk about it. So here we want to, again, NPVs, what makes the denominator equal to 0? Well, before I can do that, what's easier is factor. Factoring here, it's a difference of squares. Square root y squared is y. Square root 4 is 2. Two terms being subtracted. They're both square rootable. So we get y plus 2 and y minus 2. That's just another form of the y squared minus 4. Y squared minus 4 is y plus 2 times y minus 2. And we don't want this to equal 0. So if either of those is 0, that's a bad thing. So if y plus 2 equals 0, that's a bad thing. And that will happen if y is negative 2. It'll also happen if y minus 2 equals 0. And that happens if y equals 2. We don't want a negative 2 or a 2 because those create a 0. So our NPVs are y equal to negative 2 or 2. Or positive negative 2 is another way to write that abbreviated. So those are NPVs. We can't have denominators of 0. That's what this whole unit is going to be based on, making sure you have values that will work. This assignment will take about, hopefully, 6 or 7 minutes. Shouldn't take long. Check your answers in the back and then move on to lesson 2. Have fun with it.